Well, good morning, good afternoon, or good evening, depending on where you are in this world, and welcome to today's DevOps.com webinar. I'm your moderator, Charlene O'Hanlon, and I welcome you to today's event. Before we get started with the event, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the webinar, you'll be able to access it on demand. You'll be sent a link after the event that will take you to the webinar on demand. And we also are taking questions from the audience. So if at any time during the presentation you have a question for any of our panelists, just use your control panel, submit your question, and hopefully we should have about 15 minutes or so after the presentation to go over those audience questions. Okay, with that, we'll go ahead and get started with today's webinar, Replace Outdated Non-DevOps Tools with Innovative and Modern Pipelines. Our speakers today are Rosalind Radcliffe, who is a distinguished engineer and chief architect for DevOps for enterprise systems at IBM. We also will have Suman Gopinath, who is a solution architect for DevOps for enterprise systems at IBM, and Olivier Godin, who is CEO and co-founder of SonarSource. Welcome, everybody. Thanks for joining me today. I'm going to go ahead and turn it over to Rosalind now.
Thank you, and welcome to this webinar. Today we want to show you how your ZOS artifacts can be included in your standard DevOps pipeline and give you a little explanation for why this is a good idea and what's really going on in the industry to explain why this transformation and why now. Suman, next slide. So when we think about DevOps, it really is all about having teams work together. It's all about having the organization come together to provide this end-to-end DevOps capability to allow businesses to work, the business to work with development operations with everyone to deliver value faster. It's making sure that there are no separation, there are no silos, there's no separation in these teams. You really can build a product or a solution for your clients that provides the value. And it's all about agile and lean, bringing these processes together to help make sure that everyone really is working together, everybody really is collaborating and delivering business value as fast as possible. Next slide. When we look at the slide, you'll see in better detail how we're improving our velocity by really having all of these teams working together. And you'll see on this chart, I have the auditors, I have support staff. It's about including everyone in this process so that from the very beginning, they can work together, understand how this process is going to deliver value, and allow them to deliver that value quickly. If we think about this, bringing customers or customer representatives together with the developers, with the operations staff, all together working together, we understand that it's easier to deliver the function that is actually needed by the end users because you can have this close feedback loop. You can provide instantaneous feedback on what's being built, how it's being built, and whether or not it's going to deliver the end value. The auditors are a key piece of this because making sure that your solution provides the right audit control, the right separation of duties, matches all the requirements so that you know you can flow all the way to production. And in talking with auditors, actually, DevOps helps deliver this value through having this automated controlled pipeline. It's easier for auditors to be able to see and for companies to demonstrate that they are satisfying the quality goals, they're satisfying the audit checks, they're satisfying the separation of duties. So this is very important in this current world we live in, especially thinking about things like GDPR, or Global Data Protection Regulation, that comes into effect in just 2 days. It is important to be able to see, visibly demonstrate, and show that you are meeting these regulations. And if you think about it, there are no differences in the regulations across the different platforms. Everyone in the organization has to follow the same separation of duties, the same kinds of quality checks, the same kinds of how do I deliver this? Does it meet the right requirements? Can I prove that a developer didn't just deliver something to production without anyone else seeing the function? All of those checks are the same no matter which platform. And so having a common DevOps pipeline helps deliver this value. Next slide, please. When we think about the environment that we're in today, no organization has a single platform or a single system. Every application spans a set of platforms, a set of systems, in order to provide the true business value. Maybe it's a mobile front end through some mid-tier talking to a back-end system. Maybe it's mobile talking to back-end. You never know. There are a lot of different choices, but these systems are complex. These systems have a lot of parts and pieces, and all of these parts and pieces have to work together to provide that business value. It's important, as we're doing this, to ensure the different parts and pieces that are being developed are properly coordinated and are visible to everyone within the organization, so that you can ensure you're delivering the business value at the speed you need to. And in this picture, you see APIs. APIs are one way, this transformation to the API economy, that allow organizations to deliver business at the speed they need. But these APIs still need to be managed, they still need to be coordinated, they still need to be versioned, and they may exist in different parts of the organization. So providing API management and the appropriate controls over the APIs, as well as the rest of the system, is as important. And if these APIs cross different systems, you don't want to manage them differently. You want to make sure you have a single view into your system. If we look at this picture, I've called out a set of areas: planning and architecture, the APIs, deployment and orchestration, testing and release management. And all of these areas are key areas that there is no real difference what platform you're deploying to. You need to be able to do this with a single view. So if my application spans numbers of platforms and numbers of environments, I need to be able to push a button and deploy the whole thing. I need to have visibility to all of the work necessary to deliver a set of function. So whether that work is development activities, operation changes, doesn't matter. Everything needs to be visible in the environment so that I can see all the work to deliver that function, so I can ensure I'm delivering it on time and at the rate the organization needs it. Next slide. If we look at many organizations today, we see something like this. We see a mainframe tool stack and a distributed tool stack. Now, if you think about it, when I'm talking about DevOps and DevOps transformation. It's all about culture, all about people working together. But at the core, there is this tool stack that facilitates this ability to work together. It facilitates the ability to deliver functions at speed. It provides the underlying automation platform. And as I've been describing DevOps, it's about breaking down the silos. It's about removing the barriers. It's about removing the separation. So if you see this and the mainframe team does things one way and the distributed team does something another way, we're causing a silo. We're causing this huge divide among the development teams, operation teams on how they work. We're causing this large issue of how do I work together? If I have a totally separate system, if I have totally separate deployment systems, how do I make sure that my teams actually can work together? How do I have visibility into each side of the system? So if we're thinking about the fact that we want to be DevOps, we want to have this agile and lean culture. We want to allow the automation to provide value to the organization. We want to have a single source to be able to ensure we're meeting our quality goals, to ensure that we're doing our deployments appropriately. It's really hard to do with a picture like this. Next slide. So what if you just had one tool stack? And the important point here is it's possible. There is absolutely no reason today that you have to separate your ZOS development teams from everyone else. There is no longer anything holding you back from having a common shared tool chain, a single set of environments to allow your teams to work together, to allow them to all have the same advantages. No one that I've ever talked to would ever consider moving their distributed team into using a host-based library management for their development process. It just doesn't make sense. If it doesn't make sense for them, why does it make sense for your mainframe team? Why don't they deserve the same kinds of capabilities? Why don't they deserve the same kind of functions? And another way to look at it, everybody keeps talking about this skills shortage. There aren't enough mainframe developers. Well, if I have the same tool stack, what's so hard? Yes, it might be a different language, but most developers know multiple languages. Another language is not a big deal. And yes, they might have to learn a little bit more about the fact that ZOS is a shared system and it is highly reliable, but if the tool stack and the tools they use are familiar, are common, if they have the same way of doing things, if they're following the same processes, it's not so different. And we can help reduce this skills shortage that we have by allowing new kids or new developers to come in and work in the environment at just as efficiently as anyone else. Now you look in this list and you'll see that there are choices. We in IBM have done a lot of work to provide a tool stack that provides a full end-to-end capability distributed in Z in our collaborative lifecycle management products. So we have Rational Team Concert that can provide the end-to-end capability. But we also understand that numbers of organizations want to use open source tools. And so we've done the work to allow you to do open source tools for your ZOS development as well. So in this picture, you see Git. You see Git for a reason. There is no reason why you can't use Git in the environment just like you use it in the distributed space. So if your organization has chosen a Git or a derivative of Git, GitHub or Bitbucket or GitLab, or take your choice, no matter which one you're using, it can work just as well for ZOS. So the important point is why are we leaving the mainframe teams behind? Why are we separating them? Why don't we give them all the advantages that we give the distributed teams in doing their work? And as we do this transformation, as a mainframe developer, I need to write my Z unit, just like a distributed developer might write a J unit or an X unit. I need to be able to check that in alongside with my source. If I'm building a test case, I need to check that into the same system with my source code. Make that easy. Make it simple. Let me use the same SCM for everything. Next slide. There are also a few other reasons when we look at this environment, and it's important to recognize that the traditional host-based library managers provided real value to companies. They were built as production control systems, and they really provided value in the days before the distributed side even understood that there was an SCM. So in many ways, in the Z side, we were ahead. We had this capability. We had a library manager. We had the control of our systems. We had a standard build process, a standard deploy process. But it was ZOS only. It was very specific to the system. It provided a very strict promotion path. And it made some sense in the 1980s and 1990s, but the world has changed. There's nothing else on the planet that is the same as 30 years ago. So why are we forcing Z teams to work in that old way? Modern tools provide a true SCM. They provide branching or stream structure to allow you to work independently. As I say, they're kid-friendly. Most kids coming out of college, most students coming out of college, they know these tools. And anyone out there who's not really happy with me saying kid-friendly, first, I've been in the industry working for the last 30 years, so I count as one of those old guys that has been around for a long time. And my kids are college age. And when I think about my kids coming into this industry, my son uses Git. He already knows Git. He already knows the system. It's something that they're used to. Why not let them use that kind of tooling? Why not use tools that they're used to and are familiar with? And it's an SCM. It provides a lot of valuable capability to allow you to easily identify and understand the changes, where the changes are, and what did I include in that build when I did that build all those months or years ago. Next slide, please. Another key piece of this is in a DevOps pipeline, you have the ability to add in continuous code quality. And I'm very happy to have Olivier joining us to help describe capability in adding this quality checking into the DevOps pipeline in a consistent way across distributed and Z. Olivier?
Thanks, Rosalind. So what I would like to do is, so first, let me introduce myself. I'm Olivier Godin. I'm CEO and co-founder of SonarSource. And SonarSource is a company based in Switzerland, which develops 3 products, SonarQube, SonarLint, and SonarCloud, which are very often referred as Sonar. And we fully focus on code quality. And what I would like to talk a little bit about is the process of continuous code quality. So if you can go to next slide. Thanks. So first of all, when we refer to code quality, we actually refer to what we call maintainability, also known as technical debt, which is basically here we try to help companies to keep their software maintainable, which means that the cost of maintaining, adding new feature in the future is not gonna be too high. It's gonna be reasonable, basically. The second aspect we look at is more the reliability, where we try to find potential bugs in applications. Potential bug being behavior which are going to be different at runtime compared to what the developers thought they would be. So anything like unclosed resources, when there is like conditions which are always true, always false, it probably smells, and there is probably a bug somewhere in the code. This kind of stuff. On the last one is security vulnerability, where we try to detect things like ways of using an application in a different way than what it was designed for. So this is really what we call code quality at SonarSource. Next slide, please. And when you want to implement code quality practice in any organization, which I believe today most organizations who develop software, they try to have a practice around code quality. You have the tooling challenge, which Rosalind mentioned earlier, on which we will come back a little bit later. But you also have kind of the process challenge, which is very often this practice is coming too late in the process. So it very often comes at the time where you have finished the development. You get a lot of pushback from teams when you come to them with like a list of actions to be taken in order to improve code quality. These guys don't really like it. It's not the right moment. It's not the right version of the code that has been reviewed. There are bigger priorities, etc., etc. So lots of good reasons to not do it, which actually lead very often into a lack of ownership of the practice. So who really owns code quality in such an organization? Is it the dev team? Is it the QA team? Is it more like for the management? I tend to say that nobody really owns such a practice, which is an issue. And finally, it's very difficult to have throughout an organization some consistent requirements. Like a list of simple criteria which represents the code quality criteria for the entire organization. Very often they are different when you talk about mainframe or open, or when you outsource, offshore, in-source, when it's a young team, a more senior team, etc. So next slide, please. So all in all, it makes it very, very difficult in any organization to have a quality gate in place. A quality gate being a list of criteria that makes that if you pass, you can ship your application to production. If you don't pass, you cannot ship your application to production. So to me, it's like it's a one-to-one relationship with being able to ship code to production is a quality gate. If you have this, you have a code quality practice in place. So with all these challenges, it's almost impossible to have it. One of the aspects was that you cannot have it in mainframe anyway because you don't have the tooling, which we are now changing. Next slide, please. So we actually believe that 4 elements should be changed in this in the approach we usually have to code quality. One is dev team; they should own code quality. So basically, this should be part of the development of the non-functional requirements to deliver good code quality. The feedback loop should be short. It is very, very important. There should be a consistent quality gate across organization, and the cost should be non-significant. You do not want to have your development team to invest a lot of time into code quality. Next slide, please. How do we do this? What we actually recommend to do, and that's really what we are pushing for at SonarSource, is to approach code quality the same way you would approach a water leak. So when you have a water leak, the first thing you want to do is to actually fix the leak, because any time you would spend on cleaning the water which is already on the floor is a waste of time. It's just a matter of time before it's gonna come back. So here, when we talk about code quality, it's exactly the same thing, which is it's basically useless to look at the problems that you already have in the code, which has already shipped into production. What you should be focusing on is all the new code which gets written. And once you start to focus on the new code, then you actually do not have at all the same challenges. Of course, you can have a short feedback loop. You can do that as you do the coding, so you do not need to wait to have the big picture. You can do it as you do the coding. When a new issue is introduced, it can go directly to the developer who introduced it, which means that there will be no real pushback. Next slide, please. And the very, very nice side effect is that by having this approach, you are also automatically paying back your existing debt, because when you write, when you write software, when you develop software, by nature you keep changing it. So you make it evolve, you fix bugs, you add some new features, you change existing features, etc. So you keep changing code. Industry numbers said that we change about 20% of our code base every year. So it means that after 1 year, by having such an approach, you will have about 20% of your code which is under control. After 2, 3, 4, 5 years, you may go up to things like 35, 40, 45%, depending on how much overlap there is between years. And this is actually great. It's great because this was a painless effort, because you do that as part of the development. You are simply asking development teams to do a knock-it job on the code that they change or on the code that they add. You don't ask them to remediate the past, and you get the benefits in your entire application. Next slide. With the work which has been done on our side, so on SonarQube, SonarLint, recently we are now able to cover all aspects of code quality practice in the mainframe. So metrics rules, we are able to find duplication, to compute code coverage on the new code. There are some orchestration which are now possible for code quality analysis, and also there is an IDE integration. Next slide. Which actually means that we totally can put a code quality practice throughout development process. So in all steps of a development process, from writing code in the IDE, pushing code, we can set things so that change sets are going to be reviewed every time it gets promoted. And finally, obviously, when we go to production, we are able to review and to provide a good insight, whether it's mainframe or open technologies. It's exactly, we actually provide exactly the same data, and we are able to support exactly the same process. And I'm gonna hand it back over to Rosalind.
Thank you. Thank you very much for that. And it again demonstrates it's about process and culture and how you do work, but the tools matter as part of the process. So you're improving and selecting the right tools to ensure you have cross-platform capability in order to support the process transformation for shift left testing, to bring the testing earlier in the cycle to get the feedback sooner, using automated testing and using tools to get the right feedback. When we look at this pipeline and an open source pipeline, there were a couple of things we had to do in order to make sure that it was possible. The first was to get Git ported to ZOS, and we had Rocket Software provide that port, and so that is available. And it is the Git client, so you can use it with any Git server in your environment. The other thing we needed was a way of doing builds for ZOS, COBOL, PL1 languages in particular, assembler as well. So the traditional ZOS languages. And so we've created a product we call IBM Dependency Based Build. And this is an intelligent build system that allows you to do these builds, that understands the dependencies in COBOL, PL1, assembler, and allows you to build scripts using Groovy, which is, you know, a common language for distributed tooling, using Groovy as the language to allow you to do this process. And it integrates into any appropriate continuous integration tools such as Jenkins. But this allows your ZOS process to be very similar to the distributed process while supporting the language itself. Now, if you're using C and using make in the distributed space, you just run make on ZOS. That's fine. Java, you use the same Java build tools on ZOS that you would for any other platform. But we need something for COBOL, PL1, and the traditional ZOS languages. And so that's why we created dependency-based build. Next slide, please. Dependency-based build fits on your system by allowing you to run the toolkit in ZOS. It runs in Unix System Services, allows you to run Groovy, and it has a web app that allows you to store the dependency information as well as the build reports that are generated. It works with the Rocket Git client so that you pull the source code and then can do the build. And here in this example, you'll see we're using Jenkins as the agent to be able to do the coordination. So Jenkins is the coordinator in this case. You could use any other coordinator that ran on ZOS. Right now we have Jenkins as the example, and it's a very commonly used example. The point with this is you really can have your pipeline look just like it does in the distributed space. ZOS is just your build server that's doing the builds in the environment. Next slide. So what we're trying to do is demonstrate that I can have this end-to-end open source pipeline, and I have a development environment using Eclipse, using IDZEE and eGit to do my development. I can use GitHub, GitLab, Bitbucket, whatever I want. In our example, we're using GitHub. I'm using Jenkins as my coordinator. We have SonarQube in the example we're going to show. So you can have your open source pipeline, and it includes ZOS as one of the end targets. Next slide. So we have a demonstration that Suman's going to show, showing you the open source pipeline that allows you to do this end-to-end application deployment, allow you to do it in the same way that you're doing it with your distributed tools. So now I'll turn it over to Suman to show this demonstration of a simple application and how you can use this open source tool chain to do the same kinds of things with ZOS development that you would do in the distributed space. Suman?
Thank you, Rosalind. Hello, everyone. My name is Suman Gopinath, and I'm a solution architect with the DevOps offering team at IBM. We will now see a short demo of the tooling and the pipeline that Rosalind has just described. You will see how a developer can work on a change request and how this change then goes through an automated open source pipeline into QA. So I'm now going to don the hat of a developer. What you see on the screen is IBM Developer for Z Systems, or IDZ, and this is the modern Eclipse-based tooling that allows you to work on the ZOS just like you would work on a distributed system. So I can submit my jobs, make code changes, query DB2, and pretty much do everything that I do on ISPF. Now, as a developer, I work for an application called Mortgage Application, and this application has its source code in a Git repository. So I have my source code in GitHub, which is one of the popular implementations of Git. And if you see right here, you can see that there is an enhancement request which has been raised in GitHub to make changes to a particular COBOL program. So now what I can do is I can actually open the COBOL program in my IDZ. Now, a thing to note here is that my mortgage application source is actually stored in GitHub, but I'm able to clone it into my IDZ workspace because IDZ is integrated with eGit, which allows me to do that. And I'm able to work on this COBOL program just like I would work on a COBOL program in a PDS. And this is possible because of the IDZ DBB feature. So I have now opened the COBOL program and I can go in to make changes. So I'm going to go in there right now and make some application changes. So here I go. I have made some changes. Now, when I write these lines, you do see that there are some markers that are appearing on the screen. And this is because I have IDZ integrated with SonarLint. So like Olivier was mentioning a little earlier, it is important to have your coding checks right from the time you develop to the time when you actually do a team build of the code and move it into a development region. So at this point, because of the IDZ SonarLint integration, as a developer, when I type, I'm able to see code review, and I can make changes depending on if I have a high priority defect. I can make code changes. Now, after I make my code changes, with the DBB integration, what I can do is I can run something which is called a DBB user build. So what does this user build do? This user build copies over the source code that I've changed along with any dependencies. So I can click on this to make sure that the dependencies, copybooks, etc. required for compiler are copied over. And then it actually does a build of my source code. So the interesting thing about using a user-based DBB build is that, like Rosalind mentioned, it uses Groovy scripts. So there you are, my user build is complete. Now, what I can do is I can also incorporate, let's say, automated unit test cases, like a ZUnit automated test case, which is available with IDZ. I can incorporate a ZUnit test case along with my user build. And it will ensure that it the build not only compiles my program, but also runs the Z-unit test cases for EPS and PMT. Now, after the build is over, just like I see any other compile output, I can actually see if there were any issues. I would have seen it right here, and I can correct it. So once my changes are done, I can then go in and check my code back into GitHub. So what I'm going to do is check code back into GitHub. Where did changes? And I push it back. So now we have our change source code, which is going back into GitHub. So now let's look at the second part of the demo. So we have a developer who's used the tooling and made her changes. Now I'm going to show you how an automated pipeline looks like. So the pipeline we have in this demo is based on Jenkins. So what does this pipeline do? Now, if you notice, earlier when I made the change, I did a user build, which means that the changes are in a private data set and it's not in the actual data set which is visible to everybody. It is not, I have only just now committed changes into my main Git branch or maybe the master branch. So now what I will do is when I invoke this pipeline, it first checks out my changes along with some other changes if they have been committed by other developers for a particular change. It checks out these changes and does an application build. That is what the first step does. Okay. Now, as a second step, what it does is it takes all the application changes and invokes SonarQube and does an actual gating check. And as part of a third step, it runs some automated tests. In this case, we use XA Tester for the automated tests. And finally, it deploys the changes into QA using UrbanCode Deploy. And the deployment automation tool I've used here is UrbanCode Deploy. So let me just run this for you. Right. It has logged me out. And I've run the build. So let's see what the first Git build does. Now, as part of the actual Git build, what this step does is it invokes the DBB scripts. So the latest changes from Git that I've checked into Git are actually taken out. And the DBB actually does an impact analysis. So what it tries to do is it tries to find out what are the changed files detected since the last successful build. So this is automatically detected by the DBB scripts. And after that, the DBB build, actual build is invoked, the dependency-based build. So if you look here, you can see that there is a dependency-based build which is invoked. And while before invoking the build, there is dependency data that is collected. So if there is any dependency, like if I say, let's say if I changed a copybook, it would collect and recompile all the programs related to that copybook. And this is a choice that if you want, you can turn it on or not use it. So after build is ready, then a version is created for deployment in UCD. So this is what the first part of my pipeline does, which is the mortgage build. As a second part, you can see that the pipeline has actually gone and invoked SonarQube. So if I have to have a look at my SonarQube, what you see here is my pipeline demo with a quality gate that is passed. So an important thing that Olivier mentioned was it is very important to see if there are any new leaks that have been introduced in your code. Now, if you look at this latest SonarQube quality check that has been run by the pipeline, you'll see that there are no new bugs that have been inserted. There are no new vulnerabilities. There are no new duplications. And this is the important part because most of the times in mainframe code, you might have existing bugs because there are very large programs. But the important part is, have you, as part of your code changes, introduced anything new? And that you can see easily with the SonarQube integration. So another interesting thing to note is that if if your test cases are run with code coverage, then IDE has an option to export that code coverage in the format that's understood by SonarQube. So if you look at my test cases, you see that the code coverage is also imported into SonarQube. So I can also keep a track of my code coverage for my projects in SonarQube. And lastly, it is actually a quality gate check. So it is not just that I have passed it through Sonar, but because the quality gate has passed successfully, it has gone into the next stage, which is to start automated tests. And while doing the automated tests, what it has done is it has invoked a mortgage test suite in XA Tester here. So that the testing tool I have used here is XA Tester, and you can see that the mortgage test suite is completed. And finally, what it has done as a last bit of the pipeline is to go and invoke UrbanCode Deploy, and the changes are then deployed into QA with UCD. So if I go into my UrbanCode Deploy process, you can see that the mortgage changes have been installed successfully into the QA region. So this is how this is how a change can be easily driven from development, from the time you actually check in your code to a QA region or your system test or integration test region with automated quality gates and automated testing in place. And this really ensures that you are delivering the right code. And as and when you get into Agile and you make more and more changes more often, it is very important that you have such a pipeline in place which ensures that you have a minimum quality requirement which is met for every change that you deliver. With this, we come to the end of our pipeline demo. Before we sign off, I'd quickly like to show that the dependency-based build has a dependency portion, which actually shows you how the build result looks like and what were the dependencies, what was part of the build report, and you can see things like that. So you can see what are the outputs. So the dependency, this is the dependency-based server which stores this information. So with this, I turn this session back to Rosalind.
Thank you, Suman. And if you can go back to slideshow. Yeah. And go to the last slide. So what we want to do is now open it up for your questions. So hopefully you have posted a set of questions. I think I see that there are a few already. So let's see what questions there are.
Yeah, great. So yeah, just as Rosalind just said, if you have a question for any of the panelists, just go ahead and use the control panel. Submit your questions. We have about 10 minutes or so for questions, so we'll go ahead and dive right on in now. The first one is, does Git really work for ZOS code? So how does it work?
Yeah, so that's a really common question. Git was designed for a distributed space, and so the question comes up, how does it really work with my ZOS source? And what we had done was a port of Git to ZOS by Rocket Software. And so literally it is the exact same Git client running in ZOS in Unix System Services. And it writes the files into the hierarchical file system, normally the ZFS. So it looks the same as it does on any other platform. And you have the same distributed model that says I have a full copy of the system, the repo, everywhere I replicate it. So developers will replicate it to their local system to do work, as Suman demonstrated, and it'll be replicated to the ZOS system in order to do the builds. Now, you can build out of the ZFS and build your programs, but I know most companies are not used to doing that. So what we've done in our dependency-based build is make it very easy for you to have as the first step a process that copies the files from the ZFS along with their dependencies into PDSEs so that they can then be built. You can copy them into PDSs if you're still using PDSs, though you shouldn't be, unless it's new versions of COBOL, where you have to use PDSEs. But it'll do the copy, and then you can do the traditional compile that you've always done. So it's there, and it provides that copy feature. The other thing that we had to do in the Rocket port was add the ASCII to EBCDIC translation, because as you know, COBOL and PL1 are expected to be in EBCDIC. JCL needs to be in EBCDIC, so it's going to run in the environment. And so there is a capability that was added by Rocket to do this translation using the Git attributes. So you just specify which source code page you wish in the repository, as well as which source code page you wish when it comes out into the file system. And Rocket's port handles that for you. It all works just fine. And as you saw in the demonstration, Suman was actually editing the file in IDZ when it was in UTF-8 or ASCII. And when it loaded into ZOS, it was loaded in EBCDIC so that it could be built.
All right, great. Next question. Does this pipeline work well for both batch and online changes deployment? And are there any restrictions with either batch or CICS deployments as of date?
So it works perfectly fine, no matter what environment you're deploying to. In particular, for KICS or for IMS or for DB2 changes, UrbanCode Deploy provides a set of plugins that allow you to deploy those changes. And the KICS team builds the KICS plugin, so it allows you to do the phase in or the new copy however you wish to do it. The DB2 team built theirs so that you can literally have the system determine what are the changes between the earlier environment and the next environment and build the change necessary to then deploy that change into the environment. So those plugins are provided. It doesn't matter. You're going to build a slightly different process to deploy for batch than for online, because if it's KICS, you've got to do the phase in or the new copy, and for DB2 you need to do the binds, etc. But the process can be built so that they work just fine, and we have many customers in production with UrbanCode Deploy, including customers like Rabobank that have stood up and spoken at events on how they're using UrbanCode Deploy for both their batch online as well as configuration changes.
Okay, great. Next question. How is code coverage integrated? Is there a separate tool?
So for code coverage capture, the IBM debugger that is part of IBM Developer for Z Enterprise Edition provides that capability to turn on code coverage when you're running a test. When you're running a function, either a manual test or an automated test, a Z unit, however you've written your test. And that code coverage is then captured and can be put in a form that then can feed Sonar, as it was in this case, so that you have those reports. It also can be fed into our tool ADDI to provide another set of reporting capability and metrics.
All right, great. We're about 6 minutes to the top of the hour, so I think we have time for 1 or 2 more questions. There's still time. If you do have a question, please just use your control panel. Go ahead and get your question in, and we'll just keep plugging along here. Next question, can you use Artifactory or Nexus as the artifact repository for ZOS assets as well?
Yeah, one of the things that is common in the distributed space is an application definition. So each application has a format, so a jar or a war or a NPM or a something. And in ZOS, we really haven't had that. And so we're working on that today. But we do have, and I have the early version of an APAR that's going to allow us to take load modules out of PDSs or PDSEs and copy them into the ZFS without losing any changes. Having that, I can now actually take those artifacts and put them in Artifactory or Nexus. So we will be working on an example that we will post into the external GitHub for our DBB product to show how you can put your ZOS application, incremental or full, into Artifactory and Nexus. So yes, those are in process to being supported, and we'll have examples posted soon. I think that was the last piece that made them different.
All right, great. Okay, I have a question here, and it's a little in the weeds, so please forgive me as I'm just gonna say the question, and hopefully it'll make sense to you. It says, good for batch, online with CICS, IMS, etc., to access DB2 or not. Written supported languages, including Java, but it's not supported for WAS or WAS, right?
So the pipeline, the automated pipeline, can do Java, obviously, and UrbanCode Deploy can easily deploy into WAS, traditional WAS or Liberty, just as well as it can deploy into Kix. So this pipeline is intended to allow you to work with any of your middleware systems, actually, whether or not they're running on ZOS or distributed. So WAS, traditional WAS or Liberty on ZOS or any other platform, or Data Power or MQ or other non-IBM middleware options are supported by UrbanCode. So yes, the pipeline can work for any environment you're trying to deploy to, cloud platform or on-prem proprietary or on-prem system that you have.
Okay, great. The next question is, if the customer is implementing DevOps in a distributed environment, do you recommend doing the same implementation in Z at the same time, or is it better to do both implementations separated?
So I definitely recommend that you do them together, though you get to pick which timing makes sense. So it's not that you're going to take a company and move them all overnight unless you're a small company. If you're a large company, you will do this transformation over time. But you should absolutely move, if you're moving to GitHub or GitLab in the distributed space, that should be your target for the ZOS space as well. And you should move application by application into the solution. You don't do big bang and move everybody at once, but application by application and move each one of the teams.
Okay, great. It's about 2 minutes to the top of the hour, so we're going to go ahead and close it out on questions, but that's perfect timing because that was the last question we had. So thank you to everybody who did submit a question. Just a reminder that today's event has been recorded, so if you missed any or all of it, you can access the webinar on demand. You will be receiving a link in an email post-event that will take you to the event directly. The event will also be located on the DevOps.com website, so you can always check there. For some reason you don't get the link or you lose the link or whatever. But while you're at DevOps.com, please be sure to check out all of the webinars that we have there, both coming up and on demand. We've got some really good ones there for you. Rosalind, Olivier, Suman, thank you all for joining me today and giving such a great presentation. I appreciate it. I'm sure the audience got a lot out of it as well.
Thank you.
Great.
Thank you.
Great. And this is Charlene O'Hanlon moderating for today's event, and I'm signing off. Have a great day, everybody.